understand the term chemical reaction. Now, how you will define this chemical reaction? You can define it as any process in which two or more substance react or interact to form a new substance. That will be your chemical reaction. Example you can take as H. Example you can take hydrogen and oxygen. When they react, you see that they used to give you water. Okay, let us see the definition. Here I've written it is a process in which two or more substances form new substance. Next thing is hydrogen react with oxygen to form water. Simple as that. Now here, since you have understand the term chemical reaction, what do you mean by chemical equations? The other thing is, what do you mean by chemical equation? Now, chemical equation, it is a mathematical way, okay, to form in a formula method, so that you can understand much more easier, and it makes it too simple for us to understand. See, for hydrogen and oxygen, when they react to form water, it is too simple to understand. But when we are talking about other chemicals, when they are combining together, we don't know how much quantity they have put into it. We don't know how much it will form. Sometimes, take example of carbon. Yes, carbon plus oxygen, they will give you carbon dioxide, or sometimes they will give you carbon monoxide. So how will we know? That is why equation is a must, which help us to deal with the formula way. Okay, formula way, like here, hydrogen, okay, 2 molecules of hydrogen, 2 molecules of oxygen give us water. That is your H2O. Now this is much more simple to understand than to write in a very lengthy manner. Okay, it is much more short, plus it is very simple. Okay, all right. Now, if they ask the advantage, give the advantage for putting a chemical reaction in its equation format, then it will be like this: more simplify. The other one is more informative. I hope you got it. Okay, now let us see the next point. And it can't be reversed by physical process. You see that when you make a tea, put sugar, milk, yes. After you stir in the water, you know you got a tea. But can you reverse the process to get the milk and sugar separately? No, physically it is impossible to get it. But through chemical process, there may be some way to separate them through chemical process, not physical anymore. Alright. Okay, now when they react, what result you see? Chemical reactions involve change in state. That state will be changed. Now state, when we are talking about state, okay, we can take example of water. When we are putting in a cold freezing temperature, okay, you see that the liquid water turns into solid. Yes, solid. Next, if you put in a room temperature, you'll see the water will turn into liquid state. Another thing is that when you boil it too high, okay, you'll get gas. So the water itself is turning from solid, liquid, gas according to in which environment it is in. Now another thing is change in color. You see there are fruits around you, they used to change their color, right? When reaction is going on, some reaction is going on, because of that changing of color take place. Okay, another thing over here, change in temperature. Now have you seen the white polish which you used to put on your wall? If you put the powder in a water, you see the temperature, the cold temperature usually used to go high and it's kind of start boiling. Yes, temperature used to change in the chemical reactions. Alright, another thing is of evolution of gas. Gas will produce in some of the chemical reactions. Okay, gas will produce. Take a gas. Okay, like which reaction will produce a gas? Alright, in which reaction it will produce a gas. Next thing over here is chemical reaction have happen in our daily life. What is that? The first point I have written over here is digestion of food. You know, in your stomach there is an acid which is helping you to break down all the foods. Yes, that acid will not just be an acid, okay, some chemicals is there in it, right? So that is helping you. Another thing here is respiration. Okay, in your respiration means breathing, right? When you breathe, what kind of chemical you are taking in, what kind of chemical is going out? Respiration is about that. Okay, see, chemical reaction is taking place. Another thing is rusting of iron. You see your iron, if you put it out if you put it out for too long, you see that they will turn into reddish color, right? What is happening? Chemical reaction is taking place, okay, even though you interfere or not. If it is in present with other chemicals, some chemical reaction will take place even though it takes time. Another thing is formation of curd. I hope you know what is curd. When milk, okay, it's kept for a long term, okay, it turn into sour, or you can make it sour by putting lemon into it. See, chemical reaction is taking place. All right, now reaction occur mainly, okay, here are some picture, you can go through it. Okay, it mainly occur because of heat. Some chemical reactions, okay, it occur because of the presence of heat, or sometimes pressure, electricity. Okay, when electricity is passed, okay, in a water, you will get the hydrogen and oxygen separate it out, okay, the gas you will get. Okay, another thing is sunlight. Okay, now lastly, catalyst. Here I have written catalyst. You have all know this: heat, pressure, electricity, sunlight, but this catalyst is a new term for you. Now here, how you are going to understand is that catalyst are chemicals again. Okay, they are chemicals. Which will increase the rate of reaction. They can easily increase the rate of reaction. Now here, when you are reacting what, hydrogen, oxygen, okay, you used to put like this, right? H2O. Since we are using in equation format, here in the center, if they have undergo heat, okay, you will write heat on top of this arrow to show us whether they are involving heat in their reaction or not. If you are using electricity, you will write electricity. Sometimes for this heat, you can usually use this delta or triangle shape. Okay, for pressure, write it pressure. Electricity, write it electricity. Sunlight or light, you can write it like that. Now when we are talking about catalyst, we can write catalyst, but catalysts have substances, okay, especially they use nickel, okay, nickel to boost up the reaction. This all presence, okay, this all presence help the reaction take much more faster. So if we don't use this method, okay, some reactions needs catalyst to be boost up, okay, so here, if they ask define catalyst, your answer will be they are those chemicals that or which increases the rate of reaction without taking place in the reaction. They will not be taking place in the reaction, they will not be participating in the reaction to form a new substance, but they are just helping the reaction to increase, the helping the reaction to boost up. All right, I hope you have got the point over here. Okay, now let us see the next things: reactant, product. These two terms also you have to get it. Just now we have seen one example, like H2 plus O2 give us H2O. Yes, you have got this term, right? Now in here, plus over here help us to understand that these two chemicals are reacting together. This arrow sign help us to understand that the product is forming in this format. Okay, the product has formed into this H2O. Okay, now the chemicals which undergo reactions, okay, that will be called as your reactants. Okay, reactants, and the result which you have got will be called as your product. Okay, reactant, product. Now I have told you again, if they are going under heat, okay, you will write heat, or you can use delta directly like that, or you can use the whatever you are using in the reaction, you have to mention it. Okay, electricity. Now remember again, if you want to make it more informative, okay, more informative, the more informative, much more better to understand. Okay, if you want to make it more informative, what you have to do, you can write like this. In the bracket you can write, is it in a solid state, liquid state, or gas state? If they are in gas state, you will write G. Okay, G, and you know H2O is liquid. Okay, L, like that. All right. If they are in solid formation, okay, if they are in solid formation, in the bracket you will write S. And lastly, when you add salt, okay, when you add salt with water, okay, with water, you see that you used to get both of them together in a what, solution, right? That solution, in the bracket, what you will write, you will not write liquid. Okay, you will not write liquid. Why? Because they are in a solution now, solution, so they will be called as aqueous. Okay, aqueous. All right, aqueous. Okay, let us see the definition. Reactants who take parts in the chemical reactions. Okay, what about product? The substance which are formed in chemical reactions. Alright, now here another example is here. When magnesium ribbon is burned in air, give us magnesium oxide. Here what we can do is we can try to, when you get this kind of substances, this kind of sentence, okay, and substance over here, magnesium, what is the chemical formula? Mg is the chemical formula, right? Now is burned in oxygen, so it is reacting with the oxygen plus undergo what? Burn is what? Heat or delta, right? You can use like this. After that, what do you get? Give us magnesium oxide, so you are getting MgO. Remember that when you are writing a formula, all those tests, sodium, calcium, oxygen, or hydrogen, okay, their first letter will be in capital letter. Even though they have reacted, okay, oxygen is still oxygen, it should be written in capital letter. All right, we will see how the names, how to give their names, okay, how to write the formula in a perfect way only in your chapter 4, okay, where we are going to study about carbon and its compound. In there we will study the rules regarding the naming of a chemicals. Okay, now you can see from the name itself, it makes it too easy for us to make the formula over here, chemical equation over here, right? Okay, this this example we are supposed to do in our practical exam, but since we are in lockdown we will not be doing, but here I will show you how it is done. A ribbon has been taken, okay, after burning it you will see that white residue forming into it. This ribbon is what? Magnesium ribbon, okay, which has been taken after burning it in the presence of oxygen, okay, in the presence of air, oxygen, that is oxygen, give us this white residue which will be called as magnesium oxide. Okay, magnesium oxide. Okay, all right, now how to balance a chemical formula. Before we get into this one, okay, let us try with one simple example. After that we will see the harder one. Here you see that we have taken 2 molecules of oxygen, 2 molecules of oxygen and hydrogen, plus it used to give us H2O. O. Now here, what do you see? Why do we have to even balance them? Why do we have to even balance them after reacting? Because there, yes, in your class 10 you have studied that substance or chemicals, okay, or you can say energy, yes, they can never be created, nor they can be destroyed, okay, nor they can be destroyed, but they used to change their form. They can change their form. In your electricity, you have studied that electricity used to turn into heat energy, right? Yeah, they are not destroyed, but they are changing their form. In the same manner, in your chemicals, okay, even though they have reacted already, their their quantity, okay, how much quantity have been used, will never be destroyed or be extra will be created, okay, they will be present. Because of that, we have to balance and see whether it is correct or not, okay. So here we have taken 2 2, and in your product you have seen, you can see that H2 is correct. If you compare them, hydrogen and hydrogen, both of them have the same quantity, but when we are talking about oxygen, we see that it has only one, but over here they have two, okay. So how to balance them? To balance them, what we do is that since they are combined now, okay, they are combined now, we use the multiplication method, okay, multiplication method. Now what can I multiply with this one to give us 2, to give us this value 2, okay. So 2 ones are 2, is it not? Now this 2, okay, this 2 which I have multiplied with 1 will not be written over here, okay, it should be written over here like this. 2 ones are 2. Now our oxygen is 2, and if you see clearly that this 2 is attached with this H2O. Now since it can react with this one, it can multiply with this one, it can also multiply with 2 like this. So if it multiplies, remember, after you have solved for oxygen, don't think that it is the end. You have to make sure that the next chemicals which is right next to it, okay, are they still balanced, okay. You can see it is H2 over here. Now after putting 2 in this side, 2 into 2 will give H4, is it not? H4. So our hydrogen has turned into 4. It is not 2 anymore. And remember, balancing does not mean you should balance over this side, on your right side. You are not don't think that balancing means you will do only on the right side. No, you have to balance even on your left side to check whether they are equal or not, okay. So our oxygen is done, clear, but our hydrogen is still 2 over on your left side. So what you can do is that what will multiply with 2 to give us 4? You can simply write 2 multiplied into 2 will give us 4. Simple as that, right? So our hydrogen has formed 4, okay. Our oxygen is 2. Now in your right side also you can see hydrogen is 4 and oxygen is 2. So you can see it justified that they are balanced. Simple equation you can directly form like this, but when you got some complex, okay, some complex equation, you can use another method which I'll show you now.